Did you know that from over 500,000 tons of potatoes each year, humans create more than 3 billion cans of Pringles enjoyed around the world? And yet, they remain completely different from Lay's. Instead of being sliced from fresh potatoes, Pringles are recrafted with a perfectly engineered curve and flawless crispness, an industrial masterpiece where technology and flavor merge into one, creating a global icon of the snack world. The journey of every Pringles chip begins in the vast potato fields, where each tuber is carefully harvested, sorted, and transported to modern factories. There, instead of being cut like traditional chips, the potatoes are transformed into fine powder, then molded with millimeter-level accuracy. When you hear that familiar pop as the can opens, it's more than just a sound. It's the echo of a timeless innovation. So pop open your favorite flavor, sit back, and join Agriculture Insight as we uncover the fascinating secrets behind the chips that have taken over taste buds across the globe. Pringles was born as a revolution, a bold attempt to end the long-standing frustrations of traditional potato chips, too oily, too fragile, and bags full of air. Behind this daring idea was Frederick Bauer, a food scientist and chemist at Procter & Gamble, who transformed potatoes, and snacking itself, into a symbol of engineering precision. With over $3 billion in annual revenue, Pringles has become one of the most powerful snack brands in the world. The United States alone accounts for more than $1 billion in sales, making it the brand's largest market. Today, the iconic cans, featuring the mustached gentleman, are found in over 150 countries, each tailored with flavors refined to match local tastes and cultures. The most remarkable feature lies in its hyperbolic, paraboloid shape, mathematically designed for the perfect curve, allowing each chip to fit snugly in its can, evenly distribute pressure, and maintain flawless crispness. Containing only 42% potato, the rest made for rice and wheat flour, every chip is molded with millimeter precision. In a world ruled by spontaneity, by Lay's and Doritos, Pringles chose the path of calculated precision. So if you could only choose one chip, would you pick spontaneity or perfection? And now, let's travel to Idaho, where the cool climate and elevation of over 1,200 meters and the loose, fertile alluvial soil from the Rocky Mountains have created some of the most ideal conditions on Earth for growing potatoes. As Idaho enters early autumn, massive potato diggers begin to roll across the endless potato fields stretching to the horizon. At the front of each machine lies a dual-blade digging system with automatic depth control, guided by underground sensors. As the machine moves forward, the steel blades cut about 20 centimeters deep into the soil, gently lifting entire rows of potatoes to the surface. Immediately after, the vibrating screen mechanism kicks in, generating thousands of subtle tremors that separate soil, roots, and pebbles without scratching the delicate skins. Each row of freshly unearthed potatoes is then laid neatly on the field, ready for the next stage of collection. Behind them, specialized potato harvesters follow in formation. At the front, hydraulic lifting arms gently gather each row of potatoes, feeding them onto a vibrating conveyor that shakes off any remaining soil. Next, a 180-degree rotating belt transfers the clean potatoes into parallel transport trucks, each capable of carrying up to 25 tons. On average, a single harvester can process 500 to 600 tons of potatoes per day, equal to the work of more than 300 manual laborers. Inside the cabin, the operator oversees the entire process through a central touchscreen display, where data such as speed, vibration, soil moisture, and temperature are updated in real time. Each potato here is the result of months of meticulous care. Planted in April, watered by pure snowmelt from the Rocky Mountains, and bathed in long hours of sunlight unique to this high-altitude plateau, By the time autumn arrives, the tubers have accumulated nearly 20% dry starch content, giving them a firm texture, sweet and nutty flavor, and the remarkable ability to stay fresh for months after leaving the field. The freshly harvested potatoes then move onto the pre-sorting line. On the conveyor belt, each tuber is carefully inspected, and any that are too small, misshapen, or damaged are removed. From here, the selected potatoes are transported into massive cold storage facilities. Inside, the temperature is maintained between 7 to 10 degrees Celsius, with a relative humidity of around 90 to 95%, the ideal range for long-term storage. If the humidity drops too low, the potatoes begin to lose moisture, their skins wrinkle, and the flesh becomes soft, reducing starch quality and natural sweetness. Under these controlled conditions, the potatoes stay firm, retain their starch structure, and resist sprouting for many months after harvest. When truckloads of potatoes arrive at the factory, all the raw ingredients are unloaded into a recirculating whirlpool washing system. Inside, high-pressure water jets combined with continuously moving chain conveyors create a powerful swirling current that makes the potatoes gently tumble against each other, washing away mud, small stones, and other impurities clinging to their surfaces. A standard industrial wash tank in a potato processing plant like Pringles can hold up to 40,000 liters of water, allowing it to clean between 20 and 25 tons of potatoes per hour. After the first rinse, the stream of potatoes passes through several recirculating wash tanks, ensuring all soil and debris are completely removed. In the final stage, the potatoes enter a rotary drum washer, a stainless steel cylinder nearly 5 meters long. Inside, the drum rotates slowly at about 10 to 20 revolutions per minute, while hundreds of high-pressure water jets spray from every direction. As the potatoes tumble and gently rub against one another, any remaining fine dirt or residue trapped in the eyes is washed away. By the time they exit the drum, the potatoes are virtually spotless, their skins smooth and clean, ready for the next stage of processing. After washing, the potatoes move through an automated scanning and sorting system. Here, optical sensors and high-resolution cameras scan each potato, taking less than a millisecond to analyze its size, color, and surface integrity. Potatoes that are too small, cracked, bruised, or discolored are gently removed from the conveyor by air jet ejectors, separated for use as secondary material. Only those meeting precise standards of size, weight, and surface quality continue forward, ready for the peeling, cutting, and processing stages ahead. At this stage, the process enters a critical turning point. Inside the abrasive drum peeler, whose inner surface is lined with sandpaper-like material, the outer skin of each potato is completely removed after just a few gentle rotations. Within 1 hour, 10 tons of potatoes are transformed, leaving behind only the smooth golden flesh, ready to continue its journey. The potatoes are briefly blanched in hot water, causing their flesh to soften for smoother slicing. Inside a high-speed cutting chamber spinning at 1,200 revolutions per minute, razor-sharp blades slice the potatoes into thin pieces, then chop them into small uniform cubes. From there, the pieces move along a vibrating conveyor where an automated optical scanner inspects every fragment, and with just a tiny flaw or dark spot detected, a precise jet of compressed air instantly removes it from the line. From the cutting conveyor, the qualified potato blocks are immediately fed into a pressurized steam chamber, where saturated steam begins to define their future crispiness. Under high temperature, the starch inside the potatoes fully gelatinizes, allowing the core to cook evenly, while the outer layer becomes smooth and elastic, perfectly prepared for shaping. Immediately after cooking, the softened potatoes fall into a massive industrial mixer, where they are mashed into a smooth paste and thoroughly filtered to remove any fibrous residue. The fine mash is then spread over large rotating drying drums, where steam rapidly evaporates beneath the heated surface, transforming the mixture into thin, flexible sheets. As they peel off the drum, these sheets crisp and crack, breaking into dry flakes that are later milled into fine potato powder. This is the defining moment that gives Pringles its unmistakable identity. Inside a huge industrial mixer, the dehydrated potato flakes are blended with water, cornstarch, rice flour, wheat starch, degermed corn flour, maltodextrin, emulsifiers, and a precisely measured amount of salt. The result is a pale yellow, semi-moist dough, soft, elastic, and with a texture similar to wet sand, unlike the dry, crumbly mash used for regular sliced potato chips. From here, the potato dough moves onto a continuous rolling conveyor, where a massive steel roller compresses the warm, smooth mixture into an ultra-thin sheet, just about 1 millimeter thick, soft, elastic, and perfectly uniform, like an endless carpet of starch. Under carefully controlled pressure and temperature, the starch molecules bond tightly together, forming a stable, cohesive structure, ready for shaping. The dough sheet then passes through a rotary cutter, continuously stamping out neat oval shapes, affectionately nicknamed "dovals" by the factory workers. Any excess dough left between the cuts is immediately vacuumed back into the system to be recycled for the next batch. Frying is the most crucial stage for any snack brand. For Pringles, the edges of each slice are fixed while the center gently puffs up when it meets the hot oil, forming the iconic double-curved shape. This design not only prevents the chips from breaking when stacked, but also creates the signature saddle curve that no other chip in the world can replicate. And after all the transformations, this is the moment when Pringles finally receives its soul, the seasoning. Just 11 seconds after frying, each crisp is blasted with hot air to remove excess oil. On the conveyor belt, thousands of chips pass through a flavoring chamber, where a fine mist of seasoning powder coats every surface evenly and firmly. Each day, the factory uses around 2.7 tons of seasoning, producing more than 160 distinct flavors. From Japan's spicy wasabi, Mexico's fiery chili lime, to America's rich cheddar cheese, every Pringles chip becomes a tiny vessel of culture, carrying the taste of different corners of the world. And the most fun way to explore them? Stack multiple flavors together and take one big bite, because with every crisp snap, you might discover a combination you never imagined before. At the end of the production line, the perfectly curved Pringles slices stack themselves in flawless order on the conveyor belt, like a disciplined army falling into formation. The mechanical system then compresses them into a straight column, wraps them in a protective film, seals the metal bottom, and caps the plastic lid on top. Immediately after, the finished cans continue their march into cardboard boxes, typically 12 to 24 cans per case. Before leaving the production line, quality experts conduct blind taste tests under red lighting to evaluate crispiness, flavor, and seasoning balance. Only the perfect batches are sealed, packed into cartons, and loaded onto trucks, ready to join parties, picnics, and joyful moments shared by billions of snack lovers around the world. Few people know that ice cream was once a luxurious privilege reserved only for the elite. In ancient Rome, Emperor Nero sent his servants up the mountains to gather snow, mixing it with honey and fruit to create one of the very first frozen desserts. It wasn't until centuries later, with the advent of refrigeration technology, that this once royal indulgence slowly melted into everyday life, becoming a sweet symbol embraced by all classes. From a gift for nobles, ice cream has continually evolved into a colorful culinary universe, quirky, unique, and full of surprises. And if you ever find yourself in Turkey, don't miss dondurma, perhaps the sweetest trick of your life. Here, the vendor is not just a seller, but a street performer, teasing, spinning, pulling, and hiding the ice cream right before your eyes like a magician. Every cone of dondurma is a playful twist, cold, mischievous, and unforgettable. But behind the melting sweetness lies the resigned shake of a fitness trainer's head. A single scoop of ice cream, seemingly harmless, can contain up to 250 calories, the equivalent of an hour of intense weightlifting. That little joy, if left unchecked, can quietly wipe out an entire week of strict dieting. And now, the journey truly begins. Follow me to the dairy farms of Wisconsin, the dairyland of America, the very birthplace of the ice cream you so often enjoy. To achieve the highest quality, the cows are given a carefully balanced diet combined with proper exercise, ensuring endurance and stable productivity. When the times for reproduction arrives, mother cows receive special care so that both the cow and her calf grow strong and healthy. And the very moment the newborn calf takes its first breath, the mother's body begins producing an abundant flow of pure, nutrient-rich milk. From that stream of milk, the journey of crafting delicious ice cream officially takes its first step. When the milking season comes, the cows calmly walk into the automatic milking stations, where every step is fully controlled by advanced technology. Each animal is identified by an ear tag chip that records exact yield, milking time, and health status. On average, each cow produces 25 to 30 liters of milk per day, which is transferred directly through closed stainless steel pipelines into cooling tanks at 4 degrees Celsius, preserving freshness and vital probiotics. Just a few hours after being milked and chilled, giant tanker trucks, true mobile refrigerators, leave the farm, carrying fresh milk on its way to the ice cream factory. Inside, thick insulation and sealed tanks keep the milk in its purest state. Each truck can carry more than 20,000 liters of milk, enough to supply an entire production line. At the factory gate, samples are taken directly from the tank to test for cleanliness, freshness, fat content, and most importantly, antibiotic residues. Just one trace above the extremely low safety threshold. For example, penicillin G is allowed at no more than 0.05 parts per million, and the entire truckload, tens of thousands of liters, will be rejected immediately. Only after passing all these rigorous standards is the milk pumped into the intake system, ready to begin its journey of being transformed into refreshing ice cream. Only when the milk meets the standard of absolute purity is it moved to the mixing stage, where every ingredient of ice cream, from fresh milk, cream, sugar, and milk powder, to stabilizers and emulsifiers, is measured with gram-level precision. All of them are blended in massive mixing tanks, maintained at 40 to 50 degrees Celsius, so that the sugar dissolves quickly, the fat disperses smoothly, and every component binds evenly. Skip or mishandle this step, and the mixture will separate, sugar will crystallize, or fat will clump. Flaws that even the most advanced technology can hardly fix once the ice cream is finished. Right after mixing, the milk blend is pumped into high-speed centrifuges, spinning at up to 6,000 revolutions per minute. Within just a few minutes, the lighter cream rises to the top, while the heavier skim milk sinks to the bottom. This is the sophisticated fat filter that determines exactly how rich and creamy each batch of ice cream will be. Engineers then recombine these two parts at precise ratios, 12%, 14% fat, depending on the product line. At the same time, milk powder, sugar, and stabilizers are added to boost protein content, enhance smoothness, and maintain structural stability throughout freezing. The result is a perfectly uniform milk base, silky smooth, and ready to enter the pasteurization stage. Right after the milk base is homogenized to a silky smooth texture, it immediately enters its safety shield, pasteurization. Here, the mixture is heated to 85 to 90 degrees Celsius for about 30 minutes, or treated at a higher temperature for just a few seconds, enough to destroy harmful bacteria and deactivate spoilage enzymes while preserving flavor and nutrients. In modern production, the mold is first filled with a thin layer of the mixture, and only then is the stick inserted into its precise position. Robotic arms carry out this step with millimeter accuracy, ensuring that as the ice cream solidifies, the stick becomes a flawless bridge between frozen delight and the human hand. Inside the ice cream factory, often likened to a wonderland for millions of children, the molding process is the very moment when sweet liquid milk takes on the form of cool, frozen delights. On gleaming steel conveyors, hundreds of metal molds stand neatly aligned, each engineered with millimeter precision to create irresistible shapes, from the classic slender bar to the elegant rounded design. Automated nozzles work in perfect synchrony, pumping the ice cream mixture into each mold with precise speed and pressure, ensuring every bar is smooth in texture and free of air bubbles. Advanced technology instantly lowers the mold temperature to deep negatives as the mixture is poured, allowing the ice cream to take shape almost instantly. A single production line can fill up to 20,000 molds per hour, a number impressive enough to astonish anyone. After being chilled, the mixture is ready to begin its journey of becoming a finished ice cream. And when it comes to ice cream bars, beyond the cool cream melting on the tongue, there is a silent character that completes the experience: the small wooden stick. It may seem like it's only there to hold, yet sometimes it carries a faint aroma of wood, and many people find themselves absent-mindedly licking the stick, even after the ice cream is gone, savoring the last trace of sweetness. These wooden sticks come in many forms: short, long, round, flat, and are often recycled, ready to begin a new life cycle. Once the ice cream mixture has completely solidified inside the molds, a sophisticated mechanical system gently lifts each bar, releasing it from the icy metal surface without a single flaw. Immediately afterward, these frozen creations are guided through dipping baths or spray nozzles, coating them with layers of melted chocolate, crunchy almonds, or cookie crumbs. The coating process happens swiftly yet with precision, ensuring every bar is evenly covered, glossy, and perfect. It is this harmony between the cool, creamy core and the sweet outer shell that creates an irresistible treat loved by millions. For modern ice creams that aren't on a stick, the journey doesn't begin with cold wooden molds, but with cups, tubs, or pastry molds moving along the conveyor. Each empty container is placed precisely in its designated spot, ready for filling. Multi-nozzle pumps then work in perfect rhythm, pouring smooth layers of ice cream into each cup. Sometimes a single flavor, sometimes 2 or 3 swirled together, as visually striking as a piece of art. Immediately afterward, toppings like strawberry sauce, cookie crumbs, or melted chocolate are added before the lids are sealed automatically. As for the ice cream cone, the timeless symbol of childhood, shape takes priority above all. Golden, crisp cones are locked into place, their flared openings invitingly waiting to be filled. The filling machine must spiral the ice cream evenly, from center to edge, to create a flawless swirl, no breaks, no tilts. A precise jet of sauce is added at the peak, sometimes crowned with a peanut, a chocolate piece, or crunchy toppings, forming the crown of the cone. Every detail, from texture to aesthetics, is meticulously calculated to ensure that when it reaches the consumer, each cone is nothing less than a perfect experience. Every type of ice cream, from the classic stick bar and crunchy cone to tubs and ice cream sandwiches, has its own packaging mold and dedicated production line. Pre-printed plastic film, carrying all product information, is rolled into strips and wrapped around the ice cream at speeds of hundreds of units per minute, then heat-sealed to ensure absolute sterility. This process strictly follows international food safety standards, protecting freshness and flavor while preparing each product for its journey to millions of ice cream lovers around the world. Immediately afterward, the products are transferred into deep-freeze storage rooms, kept at a stable temperature of around -25 degrees. In this environment, the ice cream maintains its structure, flavor, and shelf life until it leaves the factory, continuing its journey to supermarkets, stores, and ultimately into the hands of eager consumers. From the sweet tale of a chocolate empire that changed America, let's journey back to where it all began. The cacao farms, where each bitter bean is nurtured to create that legendary sweetness. To encourage pollination, a portion of the husks and branches left after harvest are retained on the ground. This natural mulch helps retain soil moisture and sustains the habitat for tiny flies, the silent pollinators of the cacao orchard. These tiny flies belong to the Forsypomia genus of biting midges, measuring just a few millimeters in size. Yet they play a crucial role in pollinating cacao flowers, which are extremely small and bloom close to the tree's trunk. Without them, cacao yields could drop by up to 90%, silently shaking the entire global chocolate industry. There are two common methods of cacao propagation today: growing from seeds and cutting propagation. Growing from seeds is the simplest method, but the resulting seedlings often vary as they carry different genetic traits. In the same batch, some trees may produce exceptionally delicious pods, while others yield poorly or struggle to adapt to the climate. It's a genetic gamble that many modern farmers are no longer willing to take. In contrast, cutting propagation, taking a branch from the mother tree to grow, produces genetically identical plants with consistent yield and quality. This method is preferred in commercial cacao farms. After being cut from the mother tree, the branches are nurtured in a nursery for about 4 to 5 months to develop a strong root system before being transplanted to the field. Pruning is carried out annually, but the technique varies depending on the season and the tree's health. If the summer is too harsh, pruning is delayed until the weather cools and the rains arrive, as cacao trees are highly vulnerable to damage during extreme conditions. A cacao tree can bear fruit for 25 to 30 years, and even when it ages, farmers don't need to cut it down. By grafting a healthy young branch onto the old trunk, the tree is essentially rejuvenated, continuing to produce pods from its original root system. After years of careful cultivation, when the cacao pods turn golden red and a sweet, mellow aroma fills the air, a new chapter begins: the harvest season. In countries like Côte d'Ivoire, Ghana, and Ecuador, where the hot, humid climate and fertile soil create ideal conditions, cacao has become an essential part of life for millions of farmers. This unique tree produces pods that grow directly from the trunk, year-round without a clearly defined season. The main cacao harvest runs from October to March, a crucial window that directly influences the flavor of the final chocolate. Despite being the key ingredient behind world-famous chocolate bars, cacao is still harvested entirely by hand. Farmers use machetes or curved knives mounted on long poles to reach and cut pods from the higher branches. Each cut must be swift and precise. A wrong move can damage the stem, preventing the tree from fruiting in the next season. Did you know that only about 5% of cacao flowers successfully develop into pods? And to harvest just 1 ton of usable cacao, farmers must collect nearly 20,000 pods. In other words, every small chocolate bar carries the weight of an entire tropical harvest, built on sweat, sun, and meticulous labor. After harvesting, each cacao pod is split open using a sharp machete or a sturdy wooden stick. Inside the rough, ridged shell are plump, glossy cacao beans, wrapped in a layer of sticky white pulp that tastes mildly sweet and slightly tangy, with an aroma reminiscent of tropical fruits like mango, pineapple, and passion fruit. Beyond its unique flavor, this pulp is rich in natural sugars, vitamin C, potassium, and antioxidant polyphenols, helping to boost the immune system and aid digestion. In some cacao-growing regions, the pulp is even used to make fermented beverages or processed into natural syrups. Right after being extracted from the pods, cacao beans are quickly collected into bamboo baskets, wooden trays, or banana leaves to begin a pivotal stage, fermentation. This is the bean's transformation phase, from a bland, odorless raw material into the flavorful foundation of rich, enchanting chocolate. Over 5 to 7 days, microorganisms in the white pulp raise the temperature of the bean mass to around 50 degrees Celsius, triggering a cascade of chemical changes that develop its complex flavor. Each day, the beans must be turned to allow them to breathe and to prevent mold. Because even a single oversight can turn a batch from fragrant cacao to something sour and spoiled, like fermented pickles gone wrong. Once the beans have been properly sun-dried, they are packed into thick jute bags, durable and breathable sacks that help preserve bean quality throughout long-distance transport. Each bag weighs approximately 60 to 65 kilograms and is carefully weighed for consistency. Before leaving the farm, each bag is tagged with traceability labels, batch numbers, and farm information. The moment you step into the factory, your senses are immediately hit by the rich aroma wafting from the cacao roasting area, where raw beans are awakened at temperatures reaching 150 degrees Celsius. This critical first step unlocks the beans' signature aroma and removes their natural bitterness. The factory's advanced system can roast up to 5 tons of cacao per hour, ensuring a continuous flow of material for the next stage. After roasting, the beans are cracked open, their shells separated from the nibs, and passed through a multi-layered sifting and air suction system to isolate the nibs, the concentrated essence of cacao that defines the flavor of real chocolate. Next, the cacao is finely ground using a traditional 3-roll mill, then further refined in a ball mill, where thousands of steel balls collide continuously to create a smooth, velvety mixture. A portion of this is pressed to extract cocoa butter, the prized fat used in later blending stages. After cocoa butter is separated, the mixture is blended with sugar and milk according to Hershey's secret recipe. It's then passed through a series of rollers, where the sugar particles are finely crushed and coated in cocoa butter, forming a rich, dense paste, the foundation of Hershey's unmistakable flavor. Inside the conch machine, the mixture is heated and stirred continuously, triggering the Maillard reaction that gives chocolate its golden brown color and signature aroma. After that, the tempering process carefully cools and reheats the mixture in a controlled cycle, allowing the cocoa butter to crystallize perfectly, resulting in chocolate that's glossy, crisp, and resistant to whitening during storage. After tempering gives the chocolate its ideal smoothness, shine, and structural stability, the mixture moves straight into the molding stage, and that's where the magic moment called kisses begins at the Hershey factory. The name kisses comes from the unique motion of the chocolate as it drops onto the conveyor, gently like a kiss landing on cold metal. Once molded, the chocolates enter a long cooling tunnel, so lengthy that its end can't be seen, where they solidify completely. At this stage, a modern laser system scans each Kisses chocolate, ensuring they meet strict quality standards. Each iconic candy, with its flat base and pointed tip, is wrapped in silver foil, fitted with the signature paper plume, and gently released into a guiding chute and spiral conveyor, where every movement is precisely controlled. At the sorting station, a vibrating belt leads the candies to a smart weighing system, where containers are automatically adjusted to ensure exact weight. Once verified, the chocolates are sealed, packaged, and transferred to the boxing line. Robotic arms assist by gently shaking the packages, arranging them in boxes following pre-programmed patterns, then loading them onto pallets, ready to deliver millions of sweet little kisses to chocolate lovers around the world. Right next door, the Hershey chocolate bar production line runs at full capacity. The process begins as molds are heated to the ideal temperature, preparing them to receive streams of liquid chocolate with absolute precision. Immediately after, the molds are transferred into a large-scale cooling system where tightly controlled temperatures allow the chocolate to solidify quickly while remaining silky smooth. Once fully chilled, a gentle mechanical tap bends the molds, much like twisting an ice tray, allowing the bars to release cleanly without any cracks or breakage. The molds are then flipped, and each perfectly formed bar drops softly onto the conveyor belt, ready for inspection and packaging. At the final stage, Hershey's signature wrapping film is fed into high-speed machines that wrap and seal the bars at a rapid pace. The conveyor then rotates and positions each bar precisely so a robotic arm can lift and neatly stack them into trays for boxing. Once complete, the boxes of Hershey bars line up one after another on the main conveyor, ready to leave the factory and begin their journey to shelves around the world. Few would guess that a mishap in a popcorn factory in 1940 would mark the beginning of the Cheetos empire. During a test run of an extrusion machine, engineers accidentally created strange, puffed corn sticks, light, airy, and incredibly crunchy. But the biggest twist came from Richard Montañez, a Mexican janitor who boldly sprinkled chili powder on the snacks, giving birth to Flamin' Hot Cheetos. That daring idea didn't just skyrocket sales, it propelled him from the guardroom to the executive ranks of Frito-Lay. Mention Cheetos, and you can't ignore Chester Cheetah, the ultra-cool sunglasses-wearing cheetah draped in blazing orange cheese. Few know that when Chester debuted in the 1980s, he was initially rejected for being too rebellious and not child-friendly. But it was precisely that wild, rule-breaking persona that helped Cheetos break through, just like a cheetah smashing limits in seconds. Cheetos aren't just cheesy, crunchy snacks. They might even save your life in the wild. Thanks to their airy texture and high oil content, they ignite like dry kindling, making them perfect for starting fires and keeping warm in emergency survival situations. To fully understand the intricate journey behind every crispy Cheetos stick, we must begin at the very source, the special corn seeds planted into the soil, ready for a high-tech transformation powered by sun and soil. Across the vast fields of the American Midwest, a region blessed with dry, sunny weather ideal for starch-rich crops, giant John Deere tractors lead a fleet of precision farming machines. Modern multi-row planters move across the land, simultaneously opening furrows, dropping seeds, applying fertilizer, and covering the soil, all in a single pass. The seeds they sow are a specific type of hard yellow corn, a hybrid variety developed exclusively for Cheetos. These kernels are high in starch, low in moisture, and extremely dense, properties that ensure they puff up perfectly and deliver that signature crunch during extrusion. With annual demand reaching over 100,000 tons, every step from planting to harvest is strictly monitored to guarantee uniform quality and non-GMO compliance. From the moment the seed meets the soil to the crispy snack in your hand, it all starts here. Straight rows of corn, planted with surgical precision, now begin their life cycle, fueled by a critical element, Water. On fields reserved exclusively for Cheetos-grade corn, massive center pivot irrigation systems, stretching hundreds of meters long, rotate like giant compasses, distributing water evenly from nearby channels. Pumping up to 2,000 liters per minute, each droplet is regulated by soil moisture sensors to maintain optimal hydration. Because just a little too much or too little water each day could affect the kernel's density and structure, key factors that determine the perfect puff and crunch of every future Cheetos stick. And then, by around July, when the corn silks begin to dry up and the fields turn a golden hue, it's nature's signal that months of careful cultivation are entering the harvest season. The exciting first step in transforming corn into crispy Cheetos. Unlike sweet corn or canned corn, which are valued for their intact ears, the corn used to make Cheetos is selected based on entirely different criteria. What matters isn't the shape, but the kernel's hardness, starch content, and how well it puffs during extrusion, the key to that signature Cheetos crunch. That's why mechanical harvesting is the ideal choice. Fast, efficient, and capable of handling hundreds of hectares in just a few days. Harvesters glide smoothly across the corn rows, using sharp, rotary or serrated blades to cut the stalks close to the ground. The entire plant is drawn into the machine, where counter-rotating augers take over, stripping off the outer leaves, isolating the high-quality ears, and moving them via conveyor into storage bins or directly into transport trucks. Meanwhile, the leftover stalks, husks, and leaves are blown out the back by high-powered fans, falling back onto the field as natural mulch or raw material for composting. A high-capacity harvester can process up to 15 to 20 tons of corn per hour, equal to the output of more than 100 manual laborers working non-stop. And beyond speed, the machine minimizes bruising, preserving the kernel's structural integrity and ensuring maximum freshness. After harvest, the corn is loaded onto large transport trucks, each carrying around 25 tons, and immediately hauled to nearby processing facilities to ensure the kernels remain as fresh and high quality as when they left the field. Before we step into the processing plant, let's pass through the farms, where a semi-manual harvesting method is still in use. Workers walk along the corn rows, skillfully snapping each ear by hand and placing them onto a conveyor belt attached to a trailing tractor. By selecting directly in the field, only ears at the ideal ripeness are picked, ensuring more uniform kernels, a key factor for perfect puffing and crunch in the final product. It's a blend of sharp human judgment and mechanical power, delivering both quality and efficiency. If full mechanical harvesting is like an electric razor clearing a face in seconds, then the semi-manual method is more like a meticulous barber, shaping every detail to perfection. Both methods serve the making of Cheetos, but depending on the farming conditions, corn variety, and technical requirements, each farm chooses the harvesting style that suits them best. As soon as the corn-filled trucks arrive from the fields, their cargo is unloaded into a staging area and fed onto underground conveyor belts. From there, an inclined belt lifts the corn upward and quickly transfers it into the pre-processing zone inside the factory. Here, workers collaborate with automated sensor systems to inspect the incoming corn. Any ears that show signs of pests, bruising, or fail to meet quality standards are rejected. Only those that meet strict criteria for freshness, size, and color are allowed to proceed, ensuring consistent quality for the entire production batch. After passing the inspection stage, the qualified corn ears are fed into an automatic husking machine, where husks and silks are neatly removed within seconds. The machine uses a system of rotating rollers combined with high-speed cutting blades, all controlled by sensors to maintain consistent cutting force, strong enough to strip away the outer layers, yet gentle enough to leave the kernels intact. Each machine can process between 3,000 to 5,000 ears of corn per hour, far surpassing the output of any manual labor team. All removed husks and silks are collected and sent to a recycling or composting area, where they're decomposed under controlled temperature and humidity conditions, with the help of microbial additives to accelerate natural breakdown. Immediately after, the corn is transferred into a high-pressure washing chamber, where hundreds of clean water jets spray continuously from multiple angles to flush away dirt and impurities. In the Cheetos production process, once husked and trimmed, the qualified corn ears are fed into a specialized kernel removal machine. This equipment uses a system of rotating blades and compression rollers to separate the kernels from the cob quickly and precisely. Unlike canned corn, where the kernel's shape must remain intact, corn for Cheetos is selected for its uniformity, hardness, and high starch content, crucial qualities for the grinding and extrusion stages that follow. The golden corn kernels are then passed through a continuous washing system, where clean water sprays from multiple angles, combined with vibrating belts to remove leftover husk fragments, light kernels, dust, and any remaining impurities from the separation process. Amazingly, the amount of water used to wash corn in a single day could fill an entire mid-sized swimming pool. But in modern factories, a closed-loop system recycles up to 80% of that water, cutting waste while maintaining strict hygiene standards. After being thoroughly washed, the corn is transferred into a drying chamber set at around 60 to 80 degrees Celsius. This drying process reduces the moisture content to an ideal level, ensuring the kernels are evenly dried, mold-free, and perfectly prepared for the next step, grinding, an essential stage in the making of Cheetos. Once dried, the kernels are fed into an industrial milling system. Inside, high-speed steel rollers crush the corn into a coarse powder known as cornmeal. For Cheetos, the cornmeal must reach just the right consistency, fine enough to ensure ideal expansion during extrusion, creating that signature light and airy crunch that sets Cheetos apart from everything else. Now that the golden corn kernels are fully prepped, the transformation into crispy Cheetos officially begins. Many people assume Cheetos are just another type of popcorn, crunchy and corn-based. But in reality, crafting Cheetos is a far more complex process, starting with precisely refined cornmeal. From the silo, the cornmeal flows through pipes into automatic weighing hoppers, where each batch is measured with pinpoint accuracy and its moisture content is carefully regulated. Starting at around 10%, the moisture level is increased to 15 to 20% by adding water in precise proportions. The mixture is then fed into a large rotary drum for thorough blending, preparing it for the extrusion stage, where the real transformation begins. The extruder is heated to 280 degrees Celsius, and its internal screw spins at high speed, generating intense friction and heat that turns the cornmeal into a thick, pliable dough. Under pressure reaching up to 300 psi, the mixture is forced through a shaping die and instantly puffs the moment it hits the open air, forming the very first shape of a Cheeto. Unlike regular molding, extrusion doesn't just shape the product, it transforms it. The combination of heat and pressure fundamentally alters the corn's structure, allowing it to expand into Cheetos' signature light, crispy, and airy texture. To achieve that iconic crispy texture, the puffed corn pieces are sent into a massive oven towering up to 12 feet high. Operating at around 350 degrees Fahrenheit, the oven bakes the product for about 4 minutes. Inside, the snacks rotate through multiple stacked tiers, like a spiral staircase, ensuring every surface is evenly dried and perfectly crisped. After baking, the puffed corn pieces enter a rotating flavor drum. Here, rice oil is blended with real aged cheddar cheese powder, heated and stirred into a smooth, velvety mixture. This cheesy blend is sprayed from one end of the drum, while the snacks tumble through a 25-foot-long rotating chamber, coating each piece evenly in that bold, signature Cheetos cheese flavor. It's in that final spin where the secret cheese formula is added, the very recipe that has the world hooked on Cheetos without ever realizing why. After completion, the Cheetos are sent through an automated packaging system, where they're weighed, sorted, and sealed into individual bags. With modern technology, each factory can produce thousands of pounds of Cheetos per hour, amounting to thousands of tons of crispy snacks each year. From the classic original to the legendary Flamin' Hot, over 50 different flavors are packaged and rotated depending on the region. Each bag doesn't just hold a snack. It carries its own cheesy cultural identity from one country to another.